Well, hello, Waterway Church. We are here on a Zoom meeting right now. It is Wednesday evening, February 3rd, and Pastor Steve and I are on the line with Dr. Stuart Roop. And well, Steve, tell you what, why don't you introduce this fellow? You know him better than I do.
Yes, I sure do, Jesse. Stuart is a cousin of mine. His mom and my mom are sisters. So I have known Stuart for a very long time. And we did lots of family gatherings together at holidays and other times. And so I have known Stuart for a very long time. And as we were talking about coronavirus and about the vaccine, we wanted to talk to an expert. And I said, hey, I know somebody. My cousin is a doctor, and he's had lots of experiences at different hospitals. And he would be a great person to talk to about the coronavirus vaccine. So we've invited Stuart, Dr. Roop. I've never called him Dr. Roop. I've always called him Stu or Stuart. And so anyway, we've invited Dr. Roop to join us this evening.
Yeah, so here we're kind of picking up our Talking to Smart People series again, and so we've got a smart person. So Dr. Roop, Steve's given a little bit of a background, and tonight we're talking specifically kind of about the vaccine and just trying to get some facts because there's just all kinds of information floating around everywhere. So I guess question number one: have you received a COVID vaccine yet? And if you have, what was it like?
Yes, I have. I have received the Moderna vaccine. So if you're following at all, probably in the news, there's two different vaccines that we have in the US that are approved under the emergency use authorization. One is made by Pfizer, BioNTech, and the other is Moderna. They're both pretty similar in how they work. But I received the Moderna vaccine and just got the second dose last week. And so I'm very, very happy to have gotten the vaccine as a healthcare worker.
And so are there any, what are the big side effects that you were warned about before you took it, and have you experienced any of those?
Yeah, the side effects we did talk about, and we provide a lot of education to our folks about the side effects of vaccine. And most commonly, well, most people have very, very little side effects other than maybe a sore arm like the flu shot. But if there are side effects, the most common are things like headache, fatigue, maybe some chills, particularly the evening after you get the vaccine. Some body aches, muscle aches type thing. That's the most common. And it really is your body developing an immune response to the vaccine. Interestingly, those side effects are a little more common in younger people than they are in older, like older as in like over 65, when they divided up and looked at the side effects. It's probably, or it might be related to just the immune response and how the body mounts an immune reaction. The side effects are a little more common after the second shot than after the first shot. And again, that's thought to kind of make sense because the second shot is a little more of a booster, elevates the immune response even more. So I had more of those side effects, relatively mild. But after the second shot, I had some fatigue and some kind of chills that night, and took some Tylenol, felt fine. The next morning, maybe a little, it's hard to know what's in your head and what's real, because you're like, right, how do I feel? But maybe a little more fatigue that next day. But you know, in our hospital, we've probably had 10 to 15% of folks that really feel like they've, particularly after the second shot, that they reported that they certainly, they could tell that they had it, and either had to take some Tylenol. Some people took part of a day or a day off of work just to make sure and recover.
Yeah. And so we know that there are lots of different ways that vaccines work, and I know I'm kind of moving us along here because I know we could talk for a long time about all this stuff. Um, but can you give us, for those of us who are not doctors and don't know much, could you give us a little bit of a background? How does a vaccine like this work? I know, in the past when you get certain vaccines, there's a certain strain of the disease that's in there. Are we getting a little bit of COVID in us, or
Yeah.
what can you give us in layman's terms?
Yeah, no, it's a great question. The two vaccines that we have, both the Pfizer and the BioNTech, are called mRNA vaccines.
Mhm.
A couple of important things about that. One is that there is no virus at all in those vaccines and the way these are prepared. And that is different than, as you mentioned, a lot of other vaccines are either attenuated virus or killed dead virus that's used as part of the vaccine development. And in some cases, there could even be some risk in a live attenuated virus in someone who's very immunocompromised. But these vaccines don't have any COVID in them at all. They are just using, so mRNA is messenger, is the M, messenger RNA. And it's basically, I would see it as kind of a blueprint of how to make a protein that's injected into the cell. The DNA is in the nucleus of the cell. More an RNA or messenger RNA is a single-stranded code that is part of the vaccine. And then what our body does is sees that code and makes or reacts to what's called a spike protein. It makes basically a spike protein, so the body makes antibodies to that. If you've seen some of the cartoons of whenever they talk about COVID, they usually have this ball with a bunch of red little flowery things.
Right.
If you've seen that. Anyway, those red little puffy things are the spike protein. It's kind of a cartoon depiction of that, but these are on the surface of the virus, and the antibody that this vaccine triggers us to make are the anti-spike protein antibodies. So the body identifies that spike protein and attacks that spike protein. And so again, there's no virus in it. There's no chance whatsoever that you could get COVID from the vaccine.
Now, I've heard some of us we might have slept through ninth grade biology, and then we never really followed up with AP biology or the real heavy duty stuff. But I've heard some people when they hear about mRNA, and understanding, we've heard a little bit that mRNA kind of teaches our DNA to produce, the right kind of antibodies. I've heard a couple folks say, well, this vaccine is changing my DNA, and that sounds like a scary thing, like something almost from a science fiction movie. Is it changing our DNA? What would you say to that in just a few sentences?
Yeah. So simply no, it's not, and it really can't. The DNA is in the nucleus of a cell. This mRNA is not ever getting into the nucleus. It's just, again, providing instructions for us to make these antibodies, or actually to make the spike protein initially, and then the body produces antibodies to the spike protein. But it really, there is no chance that it's going to alter our DNA.
Okay. Well, I've got one more really kind of technical question for you before we get into some practical stuff. Is that all right?
Right. Sure.
So I know I've heard from a few folks who are maybe on the more skeptical side as far as vaccines in general, and especially as it relates to pro-life issues and that sort of thing. I know we are a pro-life church, and so we do not encourage or endorse abortion, as a legitimate action or anything like that. But I know that fetal stem cells, and for those of you who are watching, if this is beyond your concern, okay. But so I know some fetal stem cells historically have been used for the development of some vaccines. Is that the case with this mRNA? For those who are concerned about pro-life and making sure that we don't harvest anything from aborted fetuses, is that concern tied in with the Moderna or the other vaccines that are available today?
Right. Yeah. Yeah. And it's a great question. And I appreciate that's an important thing to very much. Neither the Moderna or the Pfizer vaccine, and I'm going to look at notes because I want to get the wording right here, but they haven't used fetal cell lines in the development or the production phases. So in other words, to manufacture the vaccine, and there are some vaccines that use some cell lines because part of the process is they'll infect the cell and then take part of that as part of the vaccine. These vaccines do not do that at all. However, they did use some fetal cell line cells to test whether the vaccine worked in the early phases.
Yeah. Well, I think I think we could get off deep into the weeds pretty quickly. That's a very difficult discussion to parse out. But I think the information you provide is helpful just to know how does that, as we're working through our ethics, how does that question apply to the COVID vaccine? I think that's helpful. I'm gonna, if it's all right, I'm gonna toss you a softball now. That's a little easier. Okay. Would that be all right? So, sure. Is there any idea how long, if I get this vaccine tomorrow, how long is it going to last? Is it good forever? Is it like a polio vaccine, or is it only good for a limited amount of time? What do people know right now?
I wish that was easy. Yeah, we don't know for sure. As you know, we've really only been studying these vaccines. The clinical trials started last summer. So for anyone to say, we know how long it's going to last, we don't at this point. We do have some pretty good evidence that it's a sustained antibody response. There's a thought that it's probably going to be more robust and more persistent than having had the infection, which we've been able to document antibody response usually out to, or at least out to about 5 months or so from folks that have had the infection. And particularly with the 2 doses of the vaccine, the antibody level, the antibody response is generally higher with this after the 2nd dose of the vaccine than from most people who have had the infection. But so the bottom line is we don't know how long it will last. The thought is that would hope a year or so, or maybe more, maybe a lifetime, like you've said, for some of the other vaccines. But we don't know, and it would be just guessing at this point because we don't have enough time to see how long the response lasts.
Okay.
Well, now, Stuart, we've had a number of people at Waterway who've had COVID already. Do those people need to get a vaccine?
The recommendation is that yes, it would be beneficial to get the vaccine. It's a much more predictable antibody response from the vaccine, particularly from the 2 doses of the vaccine compared to an infection, because infections, as you know, I'm sure you're very familiar with, in some cases are asymptomatic and kind of a very mild or a very mild infection, or in some cases a very severe infection. And generally the antibody response that we develop within our body correlates somewhat with that level of infection, although not perfectly. Where the vaccine is a much more predictable antibody response. After the 2nd dose, there's a really pretty robust antibody response, and we have, just very good data showing effectiveness of those. So, long answer, but the recommendation is yes, to get the vaccine, even if you've had the infection, and it's safe to get the vaccine after you've had the infection. Many of the folks, well, a good number of folks in the clinical trials had prior infection and did very well. And we've certainly given vaccine to a lot of our patients and staff who have had infection and have done well with getting the vaccine.
Okay.
And so is there anybody, I know the vaccines are only for adults at this point. I know most of them have not been approved for anyone under, certainly under the age of 16, and some of them not under 18. Is there anyone else in any kind of a, I guess I'll say kind of a typical condition who should not receive a vaccine?
Yeah, it's a good question. Very few groups that we would say not to get the vaccine. The one clear one is if you've had the monoclonal antibody treatment, if you've had COVID infection and then received the monoclonal antibody treatment, the recommendation is to wait for 90 days to get the vaccine after that. If you're acutely ill, either from the coronavirus itself or from another acute illness, recommended not to get the vaccine. There really are very few other, one other group that's been talked about is if you have a known allergy to any of the components of the vaccine, which do not include egg allergies, not include many of the common allergies that we think of. The components of the vaccine are clearly laid out. You can find it online if you look for it. But if you've had any kind of a severe reaction to a vaccine in the past, actually the recommendation is that you would we'd still recommend getting it, but you get it in a more monitored setting in a hospital, not in a small clinic, and we watch you for longer, usually 30 minutes instead of 15 minutes. But even with a history of an allergy and allergic reaction like that, the recommendation is you can still get the vaccine, just have a little closer monitoring after you get it.
Okay. And then I'm hoping you can help me with clarification. I just have this one final question. I've heard, and maybe this is a rumor, I've not done a lot of research on this myself. I've heard that that the vaccine prevents COVID symptoms, but doesn't necessarily prevent getting COVID itself. In other words, if you have the vaccine, you might be a silent carrier, but you wouldn't have any symptoms. Is that correct, or am I off? Like, so does the vaccine, does it stop the symptoms, or does it stop the transmission of the disease itself? Because that has huge ramifications for us as far as, do you continue social distancing? Do you continue all these things? You know, that seems to me like one of the really practical points. What can you tell me?
Right. So it makes a lot of sense that it would prevent both the disease and would prevent us having an active infection enough to be able to spread the virus. But that was not studied in the trials. What they did was they just monitored for symptomatic disease. They didn't test for asymptomatic viral shedding within the trials. And so we can't say for sure that there's no chance that you could have a low-level infection enough that you could be potentially shedding virus. It seems, thinking about it kind of from a disease standpoint, how we get an infection and then would be shedding the virus, seems unlikely that if we're protected from getting any symptomatic infection, that we would be able to, be infected with the virus enough that we would be shedding it and be able to spread it. So I think it's unlikely, but the recommendation still is we follow all the same precautions while we are, kind of waiting as a population to get through this and see the disease incidence come down, and hopefully, herd immunity is talked about a lot and these type of things, but we get enough people that either have immunity to the virus or the incidence of the virus is so low, then as a community, we can loosen up the precautions and things, which we are looking forward to very much.
Yeah, I guess I was kind of hoping that if I get a COVID vaccine, that I don't have to be careful anymore. I could just do whatever I want because I won't get it and I won't give it to anybody. But I hear you saying that may not be the case.
That it's a pretty reassuring that you won't get it in terms of it being a symptomatic infection, and certainly for severe infection causing hospitalization, it was literally almost prevented completely in the vaccine trials. So there's certainly a good feeling about having had the vaccine and saying, I think, I'm less likely to get it, but we don't know enough about whether you could potentially still be shedding virus and potentially infect others. So I wish we had a better answer, and it'd be more satisfying, I guess, although it would be a little hard because there's no way to know who had it and who doesn't. So people walking around and saying, "Oh, now I'm free." I mean, there's a little bit of a population aspect to this, that we all are in this together, and let's move forward until we get either low enough disease incidence or enough of us with an immunity to it that we can move forward together.
All right. Steve, did you have any other questions for the doctor?
Nope, I'm done, Jesse. That's all I. So
All right.
Thanks, Stuart. Well, I appreciate your expertise on this, and I know with your long medical history and everything that you have done in the medical field, both down in Washington and up in Lebanon, you can draw on a vast source of information for us. And so thanks.
I can tell you that it's been very exciting for us. I mean, we saw, we look at the vaccine studies. When you look at the flu shot effectiveness, for instance, each year, it's probably 50 to 60%, some years as bad as 40% effective in terms of preventing flu virus. And I know the flu shot's still very, 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 very good. But when we saw data come out in these initial vaccine studies, they were talking about 95% effectiveness. So it was very, very exciting, much better than we really had hoped for. And so that's been very exciting for us. I can tell you, among providers I work with, I don't personally know anyone who's refused getting it. I mean, the folks are very excited to get it, and we have a lot of enthusiasm. I mentioned before we got on the call that I deal much more, very frequently with people frustrated that they can't get it yet, and calling and saying, when is my turn? When is my group going to be up? And so that's we're very excited to be able to offer it, and I'm excited that we have it as a community and can start to move forward. So.
Well, Stuart, I think I do have one more question that I just thought of, and I forgot to introduce you, or forgot to ask you in the introduction. Tell me, and you and I haven't discussed this prior. Tell me about your faith.
Oh, yes. Well, thank you. Yeah. So I grew up in a Christian home, and very big part of my life all throughout. I would say kind of the big impacts for me would be I was involved in Youth for Christ as a young person in high school, and was involved with the Navigators when I was in college, which is a parachurch organization, but really a group there that, as I saw other Christians, other believers really applying their faith, how to live out the gospel together as a community with that accountability and the scripture memory and things like that. And then since then, my wife and I, we've moved around different areas of the country and just involved in different churches, and just really seeing how Jesus changes lives, and that we just being able to cling to Jesus together as a community has made a big difference. So it's been something that I'm thankful for, to have the Christian heritage in my family. I mean, Steve and I are just blessed to look back for generations in our family to see the faith and the example there. And it's been something that I have just been so thankful to be a part of. And certainly my faith and my relationship with Jesus is a big part of my day-to-day life, and it's something that every day I have to just continue that relationship and enjoy the grace of the gospel. So yeah, thank you for asking.
Yeah. Well, thank you for
hold on.
sharing with us as a brother and as a doctor and as a cousin. I
That's
appreciate it very much.
Yeah.
Thank you much. Yeah, Steve.
Hey, Jesse, just let me say that I think a lot of our people would know what church that Stuart grew up in. Calvary Monument
Yes.
Church.
Yes. Yeah, my parents still attend Calvary Monument Church. So and Bob Reed, who was the pastor when I was there, I know started at Calvary Church as well. And so my wife Donna her family grew up in Calvary Church. We were married at Calvary Church. So yeah, we have deep roots in the area here, and it's a real blessing.
Yeah. Well, thank you for being with us. Thank you very much.
Right. You're welcome. Thank you.
See you.
And so just a little bit about fetal cell lines compared to stem cells or fetal tissue. These cell lines are used pretty commonly in research. They are cells that descend from and have been grown in the laboratory from originally from elective abortions back in the 1970s and 80s. There's a couple of different cell lines that are used. Both of these vaccines use a cell line called HEK293. Not to get too technical, but those cell lines are very closely protected, regulated, and things that are used for those are approved, usually reviewed by ethics committees and things like that. In this case, the only thing they used it for was after they developed, and part of developing the vaccine, to test whether the vaccine was effective. And then it's not used at all in the ongoing production. So it's not fetal tissue. It's not the same as stem cells, but they are cells that were used to just show that the vaccine was effective. So the vaccine itself doesn't have any fetal cells, tissue, anything like that in them. But it was, they did, describe that they used it to just verify that it worked in the early part of the development before they went into, human trials and things.
Sure.
So, and it's, we can talk about that. It's there are different ways to look at that in terms of those cell lines have existed for many, many years. They're used very widely in probably almost any biological treatment commonly used for like rheumatoid arthritis, lupus, things like that. The monoclonal antibody treatments that are being used for COVID, Regeneron, which has been in the news, some they might have heard, has been used. Some of those to develop those also use some of these same cell lines and being able to test and in part of the development. So not to say that makes it any more or less acceptable. It is something that's used commonly. It's been very valuable to medical research, so I just put that out there. The other thing is there's no ongoing. So these cell lines, they're not related to ongoing, current, recent, or not dependent on future abortions. These were cells that were isolated from years ago, and then have been continued to be grown in the laboratory. So you could say that getting the vaccine now or developing the vaccine now doesn't in any way necessarily condone or encourage in any way, current abortions.